In this video, I'm going to talk about superposition theorem. Okay, so I already know about mesh analysis, nodal analysis. Why should I go with the superposition theorem? The only disadvantage with mesh analysis and nodal analysis is if there are 100 number of loops and 100 number of meshes or nodes, then you will end up with 100 equations. Okay, solving 100 equations is difficult. So I want to go with other techniques. That's not the only thing. Another point is, say for example, you have your cell phone motherboard and there is an issue, a little part somewhere here. Okay, it is connected to these 4 ports. Now, by using these theorems, techniques, I can separate this part, pull it out and find out, diagnose what's going on inside, and then change the components whatever needed and put it back, because we know that the cell phone motherboard has thousands of elements and hundreds of loops and meshes and nodes. Okay, so that's the advantage with superposition theorem. Not only superposition theorem, it is there are other theorems like source transformation, Thevenin theorem, Norton theorem, maximum power transfer theorem. In this class, I'm going to cover all those 5 theorems. Now, the first important point is there should be minimum 2 independent sources to solve the circuit by using superposition theorem. So that's the minimum requirement. At least there should be 2 independent sources. Now, another thing is, if a circuit has n number of independent sources, we need to solve the circuit n number of times. Okay. Now, the important procedure is keep one source at a time in the circuit and remove all other independent sources by using their internal resistance. What is internal resistance? I'll talk about it in a second. So here I'm talking about an internal resistance. Say for example, you have 1.5 volt battery connected to a 15 ohm. Okay, here is a 15 ohm resistor. The current passing through this is 0.1 ampere. Even if I connect the circuit, still the current is going to be approximately 0.1 ampere here and there. Now, if I connect it to 1.5 ohm resistor, a 1.5 volt battery, it's supposed to supply 1 ampere, but in reality, it is going to be around 0.98, 0.99 amperes. What's going on with the rest of the current? I'll talk about it. And here, if I connect a 0.15 ohm resistor with 1.5 volt, according to Ohm's law, I equal to V over R, you have 1.5 volt and 0.15 ohm. There should be 10 ampere current passing through it, theoretically. But in reality, the AA batteries or AAA batteries, what we use in our home, maximum, there is a current limit. They can supply maximum up to 2 to 3 amperes. I just put 2 amperes. For time being, I'm going to go with 2 amperes, but it can supply 2 to 3 amperes and it varies from company to company. Now, what is going on? What happened to my rest of the current? So basically, every source has some internal resistance. Similarly, this battery, here is the battery, has some internal resistance inside this battery. Now, say for example, we assume that there is a 2 ampere current passing through this, because this is supplying only 2 amperes of current. The battery itself can supply up to 2 amperes, so it is supplying only 2 amperes. So the voltage drop across the external resistance, which I connected to the battery, is 0.3 volt. Now the rest of the 1.2 volts will drop inside the battery. Inside the battery itself, there is a voltage drop. So now you can see, I know the current passing through this is 2 ampere, and the voltage, the resistance of this internal resistance is 1.2 times 2, this is 2.4 ohm. Okay, so what is going on? This is going to consume lots of power, so either it is damaging your equipment or it's damaging the battery itself. So do not connect very low resistance to these batteries. However, this resistance is variable. It's all depending upon what kind of resistance we are, external resistance we are, or external load we are connecting. Okay, so now theoretically this resistance supposed to be 0, but practically it varies from 0 to certain number based on the what kind of load we are connecting. So theoretically that value is internal resistance is 0. So we always take voltage source. We always take voltage source as an internal resistance of 0 ohm. Similarly, a current source, when it comes to the current source, here is a current source. Say this current source is supplying 5 amperes to a 100 kilo ohm and a 5 ampere supplying to a 10 ohms. Definitely 100 kilo ohm oppose the flow of current more than the 10 ohm resistor, right? Because it's a very big number. Now what happens here when there is a 100 kilo ohm connected, only the current passing through this is going to be some amount. I just put 4 ampere, it could be any number. The rest of the current is going to pass through this internal resistance which is parallel to the current source. Now whereas I connected 10 ohms, all the 5 amperes is going to pass through it because the resistance is very low. Okay, so that means the current passing through this, the leakage current, you can call that as a leakage current. The leakage current here should be 0 ampere. When there will be 0 ampere, so theoretically that internal resistance must be infinite. When there is infinite resistance, then there won't be any current passing through it. So for the ideal current source, we always say it has infinite internal resistance. Infinite means open circuit. Okay, if R is equal to infinite, that means it's open circuit. Okay, and if R equal to 0, that's a short circuit. So what we are going to do while doing the superposition theorem, replace all independent sources with their internal resistance, which is 0. So replace all independent voltage sources with short circuit and replace all current sources with open circuit. These 2 points are really, really important. And the third one is, if there is a dependent source, keep it as it is. Okay, do not replace it. Just keep the dependent source in the circuit as it is. So while solving the superposition theorem, keep one source in the circuit and remove all other independent sources by using their internal resistance. So voltage source has 0 internal resistance and current source has infinite internal resistance. So replace current source with open circuit and voltage source with short circuit. Now repeat the same procedure with the other independent sources. So for example, if there are 3 independent sources, so we need to solve the circuit 3 times. That's what I meant to say. Now find the total combination by adding them algebraically, all the contribution due to the independent sources. So if you're finding current or voltage, just add what is I prime, I1 prime, I2 prime, I3 prime, something like that, or I1 prime, I1 double prime, or I1 triple prime. Add those individual currents to get the final current or to get the final voltage. The only thing is, do not find power by using the superposition theorem. We can find the power only we know the final current. Okay, do not use the individual currents to find the power. So the disadvantage from this is, if there are 100 independent sources, then we need to solve the circuit 100 times. Okay, but in reality, how many independent sources are there? So for example, if you take your cell phone, what are the sources you're getting? You're going to have a battery, that's a power source. Okay, and you are getting a signal. Okay, the voice or your phone call, it's nothing but an electromagnetic wave, the EM wave. When it reaches to your antenna of your cell phone, the antenna takes it and it converts it to electrical signal. So there is another electrical signal there. So that's another input. And nowadays you're sending your data packets. So those data packets are also going to be electrical signals. So you're receiving data or sending data, electrical signals. At the same time, when you press your buttons, it knows which button you pressed based on the sending the signals. Those are also electrical signals inside. So those are the few types of inputs. Okay, so usually we will end up having only few independent sources. So most of the cases you can use the superposition theorem to solve a circuit. Now I want to solve this circuit. I want to find Ix by using superposition theorem. So here I have two independent sources. One is voltage source, another one is current source. Okay, so first step one, so there are you have to solve this circuit two times because there are two independent sources. Step one, keep 18-volt source and replace all other sources with their internal resistance. So I'm going to keep 18-volt source and replace this current source with open circuit because it's a current source. Okay, so that's what I did. I opened it. Now I can clearly see I labeled R1, R2, R3, R4, R5. My goal is finding Ix. Now since I have only one source here, I'm going to call this as Ix prime. Okay, so now I can see these three resistors are in series. Okay, since those three resistors are in series, that's going to be 24 ohms. Now I want to find the Ix prime. So to find the Ix prime, I need to find the total resistance so that I can find the total current. Let's look like a ladder circuit. So now I can see 8 and 24 are in parallel. So the resultant resistance is going to be 6 ohm. That's going to be 6 ohm. 24 times 8 divided by 24 plus 8, that's 6 ohm. Now 6 and 6 are in series. So total 12 ohms. The total current is going to be 1.5 ampere. So 1.5 ampere is going to pass through or supplied by the source. Once it comes here, it's going to split I1 and I2. So I'm going to use the current division rule. So the current division rule, Ix prime equal to total current multiplied by opposite resistance. So if I want to find the current in 24 ohms, so I can use the current division rule only when there are two resistors are in parallel. I mean, if there are more resistors are in parallel, the formula is a little bit different. So I always go with only two resistors to use the current division rules. It is easy for me to do that. Now I know the total current here, which is 1.5 ampere. Now to find the current passing through 24 ohms, use the total current multiplied by opposite resistance. What is the resistance connected in parallel to the 24, which is 8, divided by total resistance, which is 8 plus 24. I end up finding that value as 0.375 amperes. So that is the Ix prime. That is because of the only one source. Now we're going to do this step 2 or part 2. Here I'm going to replace the voltage source with short circuit. I'm going to put back the current source, 4 ampere. Now I will label this as Ix double prime. Okay. Now this is the circuit. My goal is finding Ix double prime. So 6 and 8 are in parallel. Okay. So that value is 3.43 ohm. Now that 3.43 is in series with 12 ohm. Okay, so I end up with that resistance is 15.43 ohm. At the same time, the other side I have 9 and 3, which is 12 ohms. So all I need to use Ix double prime. I can see, I mean, these two resistors, we can make it as a single resistor, 12 ohm. Okay, because those two are in series. Anyway, the current passing through the 3 ohms not only depends upon the 3 ohms, it depends upon what is connected to that branch. So 9 ohms is also connected. So 9 plus 3, 12 ohms oppose more resistance or oppose more for the flow of current. So Ix prime is going to less in this case. Anyway, so here Ix prime equal to, I'm going to use the current division rule again. So 4 ampere is going to come there. It's going to split. Opposite resistance is 15.43 divided by total resistance 15.43 plus 12. So Ix double prime, I end up with 2.25 ampere. So what is the total current? Ix equal to Ix prime plus Ix double prime, which is 2.625 ampere. Okay, thank you very much. I'll stop this video here. In the next video, I'll solve a couple of more examples. Thank you.